Good morning, AP Human Geography students. Please take a look at this map to get your brain moving. All right, we see the worst light pollution in the United States. Our topic today is population. So I want you to think about how light pollution and population go hand in hand. All right, our discussion today is chapter 2.1. Where is the world's people distributed? All right, so we'll start off with a definition. Demographers or demographics or demography is the study of people, but it's statistically broken down into not just people in general, but things like age and gender and economics, sexual orientation, think about demographics in terms of advertising. Where do advertisers want to put their bucks, right? Um, Compare Saturday morning cartoon advertisements to pro football advertisements. You're going to see, different products being sold to different demographics. Right. So again, we look at our population. We have about 7.8 billion people in the world. We are on a record pace for increase. That increase is happening in developing or less developed countries. Right. Another word we're looking at is carrying capacity. The max number that people that can fit on the earth, and this is relative to quality of life too. You could fit a lot of people if we all lived very, very simply and maybe not as well as Americans do. Or our carrying capacity could be less if people take up more resources, right? Speaking of resources, we need to compare resources to population, and then we will get something called overpopulation, right? And that's the number of people versus the consumption of resources. So overpopulation is when the resources do not match the number of people. And let's talk about our resources. Resources can be food, can be water, can be energy, it can be land, it can be any number of things, but those would be the big things that we're looking at. All right. So the book talks about population portions. This is a relatively new concept for AP Human Geography, but it basically breaks down the world into 7 different portions. Note that where population is heavy, you don't see a lot of land like India and China and Southeast Asia, right? Note that your 4, right, of the 7 are in Asia, right? You have Africa, and you have Europe with North Africa, and then you have the Western Hemisphere as 1 billion people as well, right? Again, you see varying size there. Right. If we look at where people live and where people don't live, 5% of the world lives in the blue area, and 5% lives in this tiny little red area, which is India, Bangladesh, right in there, in monsoon Asia. So if you think about where people live and where people don't live and compare it to the resources that are available there, you're going to see a lot of twos, right? People are going to live where you can find things, and they're not going to live where things are too hot or too cold or too wet or too dry, something along those lines, or too high, right? In terms of topography. So let's talk about the census, right? When we're talking about population, we need accurate data, right? The U.S. Census. This is 2020, so you are right. You are right in the mix here. We are about to get brand new numbers. The U.S. Census is very important in that it defines a lot of things in terms of federal funding. The U.S. government is going to put money where the people are, and they need to know where the people are. They also are going to put representatives in Congress, the House in particular, right? Remember, the Senate is 2 per state no matter what, right? No matter how big or how small. North Dakota has as many senators as California, right? But they do not have as many House of Representative reps, right? Congress people. So we're looking at shifting of demographics, shifting of population, And that's a very interesting time, right? And this is where we can get gerrymandering in, where we see congressional lines being redrawn. If a state loses or gains a seat in Congress, so it gets pretty wild some of the time, right? And again, we want to look at sample counting. We're looking at people who are underrepresented. Of up to 3.3 million Americans are not counted, right? And that is 1% of the population is not counted, right? But these are people who are on the margins, right? Homeless people, people living in poverty aren't as counted. All right, so there's a cartogram of the world. Again, cartograms are based on size of whatever we're counting, not on size of land. So you see that Canada is very small right in here, but you see India and China and Japan and Indonesia are very big. All right, our four major population clusters. The first one is East Asia. When you think East Asia, you need to think China with its 1.3 billion people. It's the number one country in the world at this point, although our second population cluster, South Asia, and the biggest country there, India, also at 1.3 billion, will overtake China in the next 20 or so years in terms of overall numbers, right? So in your lifetime, India will become the number one populous place. It will overtake China. Europe falls in at number 3. Now, keep in mind there aren't huge European countries, right, like an India or a China. But we do need to note that Europe is more developed, and we see urbanization as a big piece here too. 3/4 of Europeans live in urban areas, and that is a sign of development. Right? It means people aren't out in the fields. You don't need as many people out there. So we'll start to see that as well. Keep that in mind because you'll be learning about that when it comes to agricultural density at the end of this lecture. Our fourth major population cluster is Southeast Asia. Think of Indonesia, right, as the biggest country in Southeast Asia. But Southeast Asia has 1 billion people as well, total. Right? Other major clusters we can look at, the coastal Latin America, so the urbanized parts of Brazil, right, and Buenos Aires in Argentina, and then the Bowash corridor, the Bowash megalopolis in the northeast part of the United States, right? And you saw that with the map of the United States, the clustering that happened with the light pollution. All right. So what do these population clusters all have in common? Well, we can look and we can see a clear tie to coast, right, which provides not only transportation systems and trade routes, but also a source of food in fishing. We can look at near water, fresh water, not ocean water. So you'll see ties there. The Ganges and the Indus River valleys in India would be good examples of there. You see some purple, right, high density happening right there. You'll see next to land that is arable, right, land that can be farmed as well. So you're going to see some population commonalities with physical traits. All right. Also, temperature-wise, right, we see right along the 30-degree mark, we see a lot of our population in the cold mid-latitude and warm mid-latitude, as opposed to humid or polar or highlands. All right. So there's our population in the United States. Again, you're going to see clear clustering on the coasts, right, the west coast here, and then also in the northeast as well. Less so in the Midwest Plains states. You'll also see urbanization, right? Here's Minneapolis, St. Paul. You'll see the Chicago area right in here. You'll see all of the clustering that happens with that. All right, so let's talk about where people don't live. Where are the sparsely populated regions, right? We have Ecumene, which is a term that is the land that is inhabitable, that human population can live on. And this increased over history, and keep in mind it's increased to the point where 75% of the world's population lives on only 5% of the land. So that tells you how urbanized we have become. Right? We have about 55 to 60% of the world living in urban areas, and this plays out here. You'll see merely 5% of the land, 75% of the world's population. So let's talk about where people don't live. People don't live where it's dry. Think the Sahara Desert. Right? If you look at that, that is consistent throughout these four maps. They don't live in wetlands. People don't tend to live in swamps. They don't live in cold lands. You'll see that in the polar regions as well here. Northern Canada and the tundra of Siberia in Russia, right? And then they don't also live in highlands. So if you'll see that like the Himalayan mountain chain in here has always been unoccupied as well, or sparsely occupied. All right. Again, Australia is a sparsely populated area. Most of it, only 2% of the population live in that yellow region. That's the outback. You'll see a lot of clustering on the coast. All right, and our last topic of the day is something called population density. How do we measure population density? And there are three types of population density: arithmetic, physiological, agricultural. We can also talk things like housing density would also apply, but we're going to focus on these three, right? First one is arithmetic density, as in arithmetic. This is a simple equation. It is people divided by land. Right? You can look around a classroom and you take the people and divide it by the square footage, and you would get arithmetic density. So it works on scale, right? It doesn't have to be land area. It can be space in a room. Right? Monaco leads the world at 33,000 people per square mile. If you don't like people, you should probably go to Mongolia, because that only averages 5 people per square mile. Right? It's an okay number just to start off with, but it does not talk about distribution. It doesn't talk about where that population is clustered or how it is dispersed. Right? Physiological density is a little more handy in that it is people, and it doesn't take all the land, but it takes only arable land area. And arable land area is land that can be farmed. Right? And so you start thinking about this, the relationship that people have between the population and the resource of arable land. If you don't have a lot of arable land and you have a lot of people, there's a lot of pressure on that land to produce enough food. Best example of that is Egypt, and we'll see that in our next slide. Right? And our third one is agricultural density, and this is the number of farmers, not the number of total people, but just the number of people who farm divided by the farmland. So it's farm divided by farmland, and this is a measure of development. Richer countries, developed countries, do not have very high agricultural density because they don't have a lot of farmers, because those farmers have productive means to farm, and they can farm a lot of land with not a lot of people, right? Because they have things like tractors and combine harvesters and sophisticated irrigation systems and hybrid seeds and genetically modified organisms and chemical fertilizers and pesticides and insecticides and all of the things that make our farmers super productive. Our farmers in America are amazing. There's only 1.5% of our people farm, right? But we have a ton of farmland, and we get that done because we have the right tools, right? A place like Ethiopia, for example, has 80% of the people there farm. 4 out of every 5 people there farm. Right? And they do not have the productivity tools and technology to help them along, so they need more hands. So agricultural density, if you have a high agricultural density, that means you're not super developed, right? If you have a low agricultural density, that means you are pretty well developed. Right? So there's Egypt's population density, right? And we look at where it is clustered, and it is clustered near, right, the farmland. And the farmland is near the Nile River Valley. Right? Nile River Valley is a wonderfully fertile place. The rest of Egypt is pretty much desert. So you don't see a lot of people living in the sand. You see a lot of people living near the farmland. So all of this area right in here, it's not much, but all of this area, physiological density of Egypt is going to be incredibly high. You're going to see high physiological density in the Korean Peninsula. Not a lot of farmland, but a ton of people. You're going to see that in Japan. Japan is very mountainous. You're going to see not a lot of farmland and a ton of people. Right? And that puts incredible strain on the land that is available there, and also implies that places like Egypt and the Koreas and Japan are going to have to import food. They're going to have to trade. Right, so here, if you take a look, I would pause this at this point and just take a look at the arithmetic density, the physiological density, the agricultural density of Canada, the United States, the Dutch in the Netherlands, and then the Egyptians. And you're going to see, again, that high physiological density, much higher, right? You're going to see not a lot of arithmetic density in Canada. Has a ton of land, but not a lot of people, because a lot of that land is not very fertile and not very warm, right? Agricultural density, again, we look at developed places, very low, right, compared to Egypt, right? You look at your percentage of farmers and your percentage of arable land, only 0.003% of the land in Egypt is arable. So that puts incredible pressure, right, compared to the United States, where you have 2% of the land is arable, and that's a lot. Doesn't seem like a lot, but that is a ton. Compare that to the Dutch and the Canadians, right? And we have an embarrassment of riches when it comes to arable land. Right, so there's arithmetic density. Again, we see population clusters coming into play, right? 1, 2, 3, and 4 right in there. Right, here's our physiological density. That shifts, and again, you're going to see places, right? And oddly enough, China, right? Because China has 1.3 billion people. There's a lot of people dependent on every square centimeter of farmland there, right? You're going to see this in island nations as well. Not a lot of land that you can farm. So physiological density, right? And then Egypt, of course, as well. I see it a little bit in the Horn of Africa too. Right, there's agricultural density, right? And again, is this tied to development? Is this a development map? Well, it is, right? If you look at a development map, you compare the developed parts of the world, North America, Europe, Japan, and Australia, to sub-Saharan Africa, and that's a pretty good indicator that this is going to be a development map. And so there you have it.